Imagine trying to produce, thousands of liters of milk in a freezing desert where there's barely enough oxygen to even keep a heart beating.
Yeah, it's honestly a survival landscape that just breaks all the standard rules of biology.
Right. So, welcome to the deep dive. Today we are looking at this fascinating review article. It's called Health and Productivity of Dairy Cattle in High Altitude Cold Desert Environment of Ladakh, a review. And our mission for you today is to really dissect the absolute extremes of adaptation.
Exactly. We're looking at how life somehow functions when the environment is, well, actively trying to shut it down.
Yeah, and to set the scene for you, we are talking about an ecosystem situated high up in the Himalayas. The elevations range from about 3,000 to 5,000 meters above sea level.
Which is incredibly high.
Yeah.
And the parameters for survival there are just staggering. I mean, the temperatures swing violently from a scorching plus 35 degrees Celsius in the summer.
To a bone-chilling minus 35 degrees in the winter.
Right. And you add in intense ultraviolet radiation, less than 100 millimeters of annual rainfall, prolonged snow cover, and near zero humidity.
It's basically a frozen wasteland for half the year. So the immediate question, looking at those numbers, is why? Why would anyone try dairy farming in an area so overtly hostile to agriculture?
Well, it really just comes down to unavoidable necessity. Milk and dairy are absolutely foundational to the survival of the local Ladakhi population.
Yeah, and it's not just the locals, right?
Exactly. There's a massive presence of Indian Armed Forces personnel stationed in this really strategic region alongside a rapidly expanding tourism sector. So the caloric demand is immense.
But the environmental stress severely caps what any animal can actually produce.
Right, which leaves this massive chronic gap between supply and demand.
And the primary constraint driving that stress isn't just the temperature, it's the air itself.
Yeah, the sources focus heavily on the state called hypobaric hypoxia.
Right, and to visualize what that actually does to a body, imagine breathing at sea level is like drinking water through a wide standard straw. You take a breath, and your lungs easily fill with this large volume of oxygen.
Effortless.
Exactly. But up in Ladakh, the percentage of oxygen in the air is exactly the same as at sea level, about 21%. So it's the same water in the glass. But the atmospheric pressure is almost 30% lower.
So breathing up there is like trying to draw that exact same water through a tiny, narrow cocktail straw.
Right. You have to work so much harder just to get the same amount of oxygen.
Yeah, because at sea level, the weight of the atmosphere pushes oxygen molecules close together, right? And that pressure physically forces the oxygen across the membranes in the lungs and into the bloodstream.
But at 5,000 meters, that pressure is just gone.
Exactly. The oxygen molecules are spread far apart. So every time an animal inhales through that metaphorical narrow straw, the actual density of oxygen entering the blood is drastically reduced. Yeah, the baseline state for simply existing in this environment is chronic cellular level suffocation.
Which means the margin for error is essentially zero. And that actually brings us to the shifting baseline.
Right, climate change.
Okay, let's unpack this, because when people hear climate change, they usually just think, oh, global warming, things are getting hotter. But the source material shows it's much more chaotic here.
It is. The region is experiencing this violent uncoupling of its historical climate patterns. So maximum daytime temperatures are indeed rising, bringing warmer, sunnier days. But counterintuitively, the minimum temperatures are plummeting.
Wait, plummeting?
Yeah. During the winter months, from October to April, the nighttime minimums have actually declined by 3 to 4 degrees Celsius.
Man, a 3 to 4 degree drop doesn't sound dramatic until you realize, we're already starting at minus 30.
Exactly. That is the threshold where you cross from severe shivering into rapid tissue necrosis.
Cellular death. Just brutal.
And furthermore, the precipitation cycle is just crashing. The study analyzed a specific 6-year window, showing that in 2010, the region received over 265 millimeters of rainfall.
Okay.
But just 5 years later, in 2015, that number had plummeted to roughly 52 millimeters.
52? That's like an 80% reduction.
In an area already classified as a desert, and they rely heavily on glacial meltwater for agriculture. Only about 20 to 30% of villages have alternative fresh water, and those glaciers, they're receding rapidly.
And when water does arrive, it isn't arriving as usable rain. The terrain is responding to the atmospheric changes with these sudden, catastrophic cloudbursts.
Yeah, the sources highlight massive flash floods in August 2010 and 2015.
Right, instead of watering crops, these events literally shear the topsoil off the mountainsides. They wash away entire agricultural terraces.
The system is just swinging wildly between extreme drought and devastating floods.
And this has a profound ecological consequence, right? Like the native yaks.
Oh, this is fascinating. So the rising daytime temperatures are physically altering the habitat zones. Native yaks, which are biologically specialized for extreme cold, are now being forced to migrate to even higher altitudes just to escape the warm, sunny days.
Wait, so they're getting pushed up into the sky?
Basically, yeah. They climb higher to find the cold they need, and they start encroaching on rare alpine flora and fauna that have never had to compete with large grazing animals before.
It's wild. The whole ecosystem is being compressed toward the peaks. But, going back to the dairy cows, with the water cycle shattered and the climate so unpredictable, the immediate crisis for the farmers is just finding fuel.
Food, yeah. You can't produce milk if you don't have fuel.
Exactly. Think of a dairy cow like a home heating system.
Hmm.
Just like your house needs way more fuel to keep the rooms warm during a blizzard, these cattle require a massive amount of dietary energy merely to maintain their body temperature.
Only whatever is left over can actually be used for making milk or reproducing.
Right. And the caloric math in Ladakh is incredibly unforgiving. Cultivable land is so scarce.
Yeah, only about 20% of the cultivable land in the district is devoted to growing fodder.
Fodder being mostly lucerne, right? Like alfalfa.
Exactly. And the rest of the land, the other 80%, is strictly reserved for human grain production, like barley and wheat.
Which makes sense. Human survival has to overtake agricultural optimization. But what do the cows eat during the long winters when they're entirely stall-fed?
Well, farmers have to get incredibly resourceful. They rely on local grasses, wheat straw, crop residues, and even things like apricot pomace and apricot cake.
They're just extracting every single kilocalorie from the environment. And this leads to my favorite part, the tree leaves.
Yes, the willow and sea buckthorn leaves.
Right, because on the surface, feeding a cow dried willow or poplar leaves sounds like desperate, empty filler just to stop their stomachs from shrinking.
It definitely appears that way. But the science shows these locally available tree leaves are actually acting as high-altitude medicine.
How so?
Well, they contain valuable proteins and minerals, sure, but crucially, they are incredibly dense in natural antioxidants.
Okay, let's break down the mechanism there because we hear antioxidants all the time in health food marketing, but here it's literally life and death.
Absolutely.
Because these cattle are breathing through that narrow straw of hypobaric hypoxia, their cells are constantly starved of oxygen. And when the mitochondria, the power plants of the cells, try to generate energy without enough oxygen, they become inefficient.
Right, and they start leaking free radicals.
Yeah, these highly reactive molecules that physically tear electrons away from the animal's own cell membranes, which causes massive tissue damage.
Which we call oxidative stress. And the toll of that is systemic inflammation and muscle breakdown.
So how do the leaves help?
The antioxidants in things like sea buckthorn act as chemical scavengers. They neutralize those free radicals before they can damage the cellular structures. So the farmers are inadvertently providing a specialized biochemical defense mechanism just by feeding them local leaves.
That is amazing. But, since high-quality feed is still scarce, the farmers also have to tackle the other side of the thermal equation. They have to conserve whatever body heat the animals actually generate.
Right, which leads us to how they house the cattle.
Yeah, the traditional Ladakhi livestock housing. It's essentially a thermal bunker.
Exactly. Semi-underground mud houses. They had these incredibly thick insulating walls, roofs covered in dry grasses, and almost zero ventilation.
Right, and during heavy snowfalls, farmers even bring in bukhari, which are these traditional artificial heaters, to keep the herd alive.
The whole goal is to create a closed loop so no ambient heat escapes.
But this raises an important question, right? If you seal a room tight to keep the heat in, aren't you trapping everything else in there too?
You are. And that is a huge problem. Because there's no drainage and dung and urine are only cleared out every 5 to 6 days, the poor ventilation traps massive concentrations of ammonia and moisture.
Oh, wow. So they're just breathing that in.
Yeah. The urea breaks down into toxic ammonia gas. It creates this incredibly unhygienic, caustic environment that chemically burns their respiratory tracts.
So it predisposes them to respiratory infections.
Exactly. The very thing keeping them from freezing to death is threatening their lungs.
Man, that is a devastating irony. And it brings us to the internal battle. We've talked about how humans adapt the external environment with feed and shelter. But how does a cow's internal biology adapt to the narrow straw of oxygen?
Well, to compensate for the hypoxia, the body triggers a massive systemic response. The kidneys detect the low oxygen and release a hormone called erythropoietin.
Which commands the bone marrow to pump out more red blood cells.
Right, the hemoglobin concentration spikes so the blood can carry more oxygen.
But if you pack the blood with excess red blood cells, you completely change its fluid dynamics. It's no longer a thin liquid,
It's like trying to pump a viscous syrup through the vascular system.
which requires significantly more mechanical force from the heart.
And here is where it gets lethal. When the lungs are starved of oxygen, the pulmonary blood vessels naturally constrict. It's supposed to divert blood to better oxygenated areas.
But at 5,000 meters, the entire lung is starved of oxygen.
Exactly. So the entire vascular network constricts simultaneously. The heart's right ventricle now has to push this thickened, syrupy blood against a wall of constricted high-pressure vessels.
Which causes right ventricle hypertrophy. The heart muscle just thickens and enlarges from the sheer strain. And the sources point out this culminates in a condition called brisket disease.
Right, which is essentially high-altitude congestive heart failure. The right ventricle fails, fluid leaks into the tissues, and pools in the lower chest, the brisket.
The animal basically drowns in its own fluids.
It's awful.
Here's where it gets really interesting, though, the genetics. Because the native Ladakhi cow is a small, hardy animal. It yields very little milk, only about 1.5 to 4.5 liters a day.
But the milk is incredibly rich. The fat content is unusually high, sitting between 4.9 and 5.2%.
Right. But obviously, agricultural programs want more volume, so they try to bring in exotic breeds from the plains, like Holsteins or Jerseys, which produce way more milk.
But their bodies simply can't handle the stress. A Holstein is genetically programmed to prioritize milk production over its own survival.
So if it can't eat enough calories to fuel the furnace and make 15 liters of milk,
It cannibalizes itself. It enters a catastrophic negative energy balance. It breaks down its own fat, muscle, and even leaches calcium from its bones.
which leads to milk fever.
Exactly. Parturient paresis. The animal collapses. Their genetic programming becomes a fatal flaw up there.
So what's the ultimate hack? The farmers realize exotic breeds die, so they do something brilliant.
They crossbreed the native cow with a yak.
Yes, the yak brings the thick coat, the large lungs, the extreme cold tolerance.
And when crossed with a cow, the male offspring is called a doe, which is a sturdy draft animal. But the female is the zomo.
The backbone of the Ladakhi dairy industry. She gives that rich milk, but actually survives the winter.
But even the zomo has limits. They can't tolerate the summer heat at lower altitudes. And regardless of the breed, the extreme cold stress forces all these cattle into a massive reproductive compromise.
Right. The sources show their calving interval stretches to an astonishing 2 to 4 years.
Because their bodies shut down reproduction just to prioritize basic survival.
It's a masterclass in biological balancing acts. Every drop of milk is a victory against hypobaric hypoxia, freezing temperatures, and feed scarcity.
It really is.
But, we should leave you, the listener, with one final provocative thought that builds on that climate data we mentioned earlier.
Yeah, the sources mention that the warming climate is actually bringing new parasites to the region.
Right, ticks causing diseases like babesiosis.
Exactly. These high altitudes used to be too cold for them. They were sterile. But now, these vector-borne parasites are climbing up the mountains, destroying the red blood cells these animals desperately need.
And as the native yaks and the herds move higher to escape the heat and the bugs, what happens when they finally reach the peak and run out of mountain? Is there a ceiling to adaptation?
It's a terrifying thought.
It really is. Thank you for joining us on this deep dive. Keep exploring the wonders of adaptation, and we'll see